Good morning to all. My name is Arvind from Computer Science Engineering. Today's my topic is about drift currents. Outline. I explained in these topics introduction of drift currents and carrier drift, drift current equations, p-type and n-type diagrams, and conclusion of drift current. Introduction of drift current. The flow, the flow of charge carriers which is due to the applied voltage or electric field is called drift current. Here the flow of charge carriers which is due to applied voltage or electric field is called drift current. Applied voltage or electric field due to when the voltage is applied to a semiconductor, the free electrons move towards the positive terminal of a battery and holes moves towards the negative terminal of a battery. Here the diagram locates flow of holes, flow of electrons and free electron voltage given. Carrier drift, the process in which charged particles move because of an electric field is called drift. The process in which charged particles move because of an electric field is called drift carrier. Charged particles within a semiconductor move with an average velocity proportion to the electric field. The proportionality constant is the carrier mobility. Here hole velocity Vh Pe notation MP, hole mobility centimeter square, and Mn is electron mobility centimeter square. Drift current is proportional to carrier velocity and carrier concentration. Here diagram shows that here Vh Ta equals to volume from which all holes cross plane in time t. P is holes crossing plane in time t. The holes crossing in plane time t. Here Qp equals to charge crossing plane in time t, and Qp Vh A equals to charge crossing plane per unit time equals to hole current. Here hole current per unit area, that is current density, Jp drift QPV. Here Jp drift equals to QPV. Drift current equations for undoped or intrinsic semiconductor, N equals to P equals to N. For electron, Jn equals to NQE mu N. Here J is the drift current for electrons and N is number of free electrons per unit volume and mu is mobility of electron for electron. For hole, here Jp equals to P into Q into E mu P. Drift current for holes, here Jp is drift current for holes. Here P is the number of free holes per unit volume and mu P is mobility holes. Drift current equation, total current density, that is J, I is current, here Je plus Jh, J, that is NQE mu N plus PQE mu P. Since N equals to P equals to N, that is current I. NQ into mu N plus mu P into E. Here I is for a pure intrinsic semiconductor. Here the picture shows p-type and n-type, that is hole diffusion, electron diffusion, uncovered space charges. Here p-type in n-type, electron drifts, hole drift, that is uncovered space charges. And conclusion, drift current is a fundamental concept in electromagnetism, refers to the motion of charge carriers such as electrons or holes under the influence of electric field. This current is crucial in understanding the behavior of electrical circuits and the operation of various electronic devices. It is characterized by the drift velocity of charge carrier, which depends on the electric field strength and the material's properties, including carrier mobility and density. Here, the drift current is a fundamental concept in electromagnetism. It refers to motion of charge carriers and as electrons or holes under the influence of an electric field. This current is crucial in understanding behavior of electrical circuits. This current is a very understanding behavior of electrical circuits, operations of various electronic devices. It is characterized by drift velocity of charge carriers, which depends on the electric field strength and materials properties, including carrier mobility and density.